for anybody absent. 6.2 notes are on central tendency and dispersion. There are ways to describe data besides histograms and frequency tables, what we just talked about. So 6.1 was on those tables and histograms. In 6.2, we're going to go back to those three measures that you learned about in statistics sometime in junior high school. I'm almost positive. I'm not even sure if you touched it in 6th grade or not. But let's write down measures of central tendency. This is what we're going to start with. Measures of central tendency. Measures of central tendency. There are three measures of central tendency. You've heard of them before, but we're going to write them down. Mean, median, and the mode. When your worksheet asks you to figure out what the best measure of central tendency is, they are asking you to figure out what data, which of these three measures will summarize the data best. And I'm going to hopefully give you enough hints that you'll be able to figure out which one is the best one to use in which case. So if you have not figured out already, let's write down how to find the mean just in case you need notes on that. Let me go over here. The mean is your average. Aver, A-G-E, Mr. Paramo, E-A-V-E-R, average. Average. It's the total sum divided by the total population. I'm writing really small, I'm sorry. For those of you who don't squeeze it very in. Total sum, adding up all the numbers divided by how many numbers you have. If you need more detail, it's your total sum. You're adding up all the numbers and you're dividing it by how many numbers you have. Just in case you need that. That's how you find the mean. The median, on the other hand, is the middle number when it's the middle number when in order from smallest to largest. It's the middle number when in order from smallest to largest. The mode is the most used number. Underneath the mode, I have a little side note. No mode is okay. Sometimes there is not going to be a mode, and that's okay. 2 modes are okay as well. Sometimes you might have 2 modes. We call those bimodal. I won't ask you that question. But if you go into statistics after Math 2 or Math 3, you will learn about that as a bimodal graph. Okay, so on this next worksheet, they're going to ask you to describe data in terms of these measures of central tendency. So you're going to have to be able to find the mean. You're going to have to be able to find the median. You're going to have to be able to find the mode. So let me give you an example, like let's do number 2. So look just like number 2. Number 2 says 3, 5, 5, 2, 4. The directions for number 2 will say find mean, median, mode, and which best describes the data. Scoot that over just a little bit. There we go. Find the mean, median, mode, and which best describes the data. I have 3, 5, 5, 2, and 4. The first thing that I always find is the median. Because the median, you have to do something first. Let me go up here where it says median, and it says the middle number when in order from smallest to largest. So this is the very first thing that you have to do. The first thing I always recommend, always write your numbers from smallest to largest. I'm going to put that off to the side here. Write numbers smallest to largest. That makes everything a little bit more easy finding the median. Write your numbers from smallest to largest. Okay, so what's the smallest number?
2.
Ooh, 2. Then what number?
3.
Then what number? Then what number? Then what number?
5.
Okay. So the very first thing that I do is I write the numbers from smallest to largest. That's going to help me find my median. So the median is the middle number when they're in order. They have to be in order first. Don't look at the middle number up here. You got to look at the middle number when they are in order. 1, 2, 3, 1, 2, 3. It's the middle number. If there's an even number, you have to take the average of the 2 middle numbers. But the middle number, so this number, since it's in the middle, it's by itself, this is the median. The median is what number? It is 4. We found one of the measures that we're supposed to find. The next easiest one to figure out is the mode. The most used number. What number is used the most in this particular problem? Those are the 2 easy things to figure out. We have the median, which is 4. We have the mode, which is 5. The last one that we need to find is the mean. I do recommend you use a calculator. If I'm trying to find the mean, It's the average. I need to do the total sum, which means all the numbers added together divided by however many numbers you have. So when I look at this, I have 2 plus 3 plus 4 plus 5 plus 5 divided by how many numbers do I have? Oh, not by 19. How many numbers do I have here? 5. That's called the population of the data. I do recommend you use your calculator. I also recommend you use the fraction button as you're doing these by hand. So let me slide that over just a little bit. Here's the fraction button right there. On top, 2 plus 3 plus 4 plus 5 plus 5. Divided by 5. This calculator will give it to you as a fraction. I want you to switch it to a decimal. What is the mean? What is the average of the numbers that you see here? 3.8. So we have answered the first part of the question. Find the mean, median, and mode. We have the mean, the median, the mode. I recommend you put them in order. Then I look for the most often used number. Then I find the mean last. That's how I always do every single one of these problems. Now the harder question is the second part. Which best describes the data? You're going to have to choose one of these. You're going to choose the one that best describes the data. And how I always choose it is going to be based off of these two things. Okay? The average is a great choice to pick as long as there's not an outlier. The mean, let's write this down. Best describes the data when there is no outlier. The mean best describes the data when there is no outlier. An outlier is a number that is way far away from the other numbers. So what I do when I look at this is I look at 2, 3, 4, 5, 5. Are all these numbers really close to each other? Are all these numbers kind of next to each other on the number line? If so, the mean best describes the data when there is no outlier. If there was one number that was way far away, for example, when we were doing ages, remember how close you guys were to each other? Then we had a couple of outliers. We had Ray's age, and then we had Mr. Paramo's age, which was, north of 30. Mine is way far away from all of your ages, right? That's an outlier. So let's write this down right below what we just wrote. If there is an outlier, the median best describes the data when there is an outlier. The mean best describes the data when there is no outlier. The median best describes the data when there is an outlier. And I want to write down why. Ray, you have a question?
Yeah.
Go for it.
So, for that class sticky, I'm technically not an outlier because you did 13 and 14 right after that.
Yeah, you're really close to it.
And we didn't do your age, so.
Right. But I would be in that. That was my example. I would be, since I'm so far away from your guys' age. Yours is not really an outlier. You're absolutely correct. Because there may have been some 13-year-olds in there. Okay. How come medians, I want to put this right here in a little parentheses. Medians are least affected by outliers. Medians are barely affected by an outlier. An outlier does not move a median very much. Doesn't move it at all practically, which is why home prices are best described by medians. If we look at the median, they talk about this in real life when they talk about home prices or the values of houses. Like, for example, across the street, the median of the houses that are literally on the other side of Teague, right there between Minnewawa and Peach. The median somewhere in the $550 range, maybe even $600,000 houses that are right there. They describe that because there may be a house that's in there that might be $900,000. There may be a house in there that's $300,000. There might be some outliers in those houses. But those outliers least affect the average of those homes. Okay, there's one other one that we can choose, the mode. The mode best describes popularity contests. I'm just going to put popularity. I'm not going to put a contest there. Best describes popularity. If we were talking about who are we going to vote for class president, Ralphie says it's him.
I vote for Ralphie.
There you go. When we choose which one's going to be the best description, if we all voted for who is going to be the class president, the mode is the best one. We want to know the most often picked candidate. That's who's going to be at the top of our list. But if we're not talking about a popularity contest, we are going to choose either the mean or the median, depending whether there's an outlier or whether there's not an outlier in the data. Okay, I have one more example for you. Oh, and I have one more word to define, which is range. Okay, range is your largest number subtracted by your smallest number. You will be asked to find the range on problems like number 9. So if I say, what's the range of ages here, including Mr. Paramo, you'd have to take my north of 30 age, and you'd have to subtract it by Ray's age, and that's the range of ages in this classroom. It's somewhere your age falls between Ray and myself. That's what range means. How far, what numbers are we going to use? The last example that I need to give you is how to figure out a set of data that has a specific mean. Let me give you an example. Let's look at number 5. Number 5 says 14, comma, 10, comma, 17, comma, 9, comma, x with a mean of 14. 14, 10, 17, 9, x with a mean, an average of 14. So what this is saying, if you have 1, 2, 3, 4, 5 pieces of information and you want an average of 14, what does this number have to be? This is very useful for you if you're trying to figure out, what do I need to get on the final to keep an A? That's how this is going to work. If you're like, I have this test, this test, this test, this test score, what do I need to get on this to have an average of a 14? Not that you would want an average of 14. You might want an average of a 90 or something. This is how you do it. So how are we going to do it? We're going to take these numbers, 14, we're going to add 10 to it, we're going to add 17 to it, we're going to add 9 to it, we're going to add x to it. And how many numbers do we have of these numbers right here, including that x? Divided by 5 should equal an average of 14. What we do is we take all these numbers, including this unknown number that we don't know what it is. We're going to add it to all these numbers and divide by 5 because we know x is going to be a number. And then what we need to do is to do the opposite of dividing by 5. I'm going to get rid of the whole thing divided by 5. What I'm going to do is I'm going to multiply both sides by 5. So let me put 14 plus 10 plus 17 plus 9 plus x divided by 5. And what I'm going to do is I'm going to take that whole thing and I'm going to times it by 5 on this side. And I'm going to times it by 5 on this side. What will happen is that the 5 divided by 5 reduces, goes into each other one time. They cancel each other out or reduces to 1, and 1 times anything is itself, so we don't need to write the 1. Then we have 14 times 5. I don't know what that is, so I'm just going to do 14 times 5 on my calculator. Ooh, Ray knows it. 70. I'm just going to go right down to there and put 70. Equals 14 plus 10 plus 17 plus 9 plus x. Now what we can do is we can add these 4 numbers together. Simplify it. 14 plus 10 plus 17. So what does that mean? 50 plus x is equal to 70. And then I bet you could figure out what x is now. X is equal to what number? Because you can subtract 50 and subtract 50, and now you get what the answer has to be. Let's stop our notes right there.